Yes, the James Webb Space Telescope, JWST, has indeed captured 3I/Atlas, the third confirmed interstellar object entering our solar system, for the very first time. Highlights from the observations include: out there, in the silent, unending blackness of space, a traveler has been journeying for longer than any of us can truly comprehend. Imagine a cosmic ghost, a silent wanderer drifting between the stars for millions of years, perhaps even billions of years. It has witnessed the birth and death of distant suns, sailed through nebulae of incandescent gas, and carried with it the ancient secrets of its own long-lost home. This isn't science fiction, this is real. This is the story of 3I/Atlas, an interstellar object that has just crossed the threshold of our solar system, bringing with it mysteries from a place we've never seen. Its arrival was a whisper at first, a faint blip on our most powerful telescopes, but it quickly became the focus of astronomers worldwide. The anticipation was electric. Floating in my own spacecraft, I often looked out the window at the Earth below, and then turned my gaze outward, to the infinite starfield. You feel a profound sense of connection to that vastness, but also, a deep curiosity about what's out there. The discovery of an object that originated from another star system is one of the most exciting events in modern astronomy. On a quiet day in August of 2025, history was made. The James Webb Space Telescope, our magnificent golden eye orbiting 1,000,000 miles from Earth, swiveled its mirrors to focus on 3I/Atlas. From its vantage point at Lagrange Point 2, Webb is perfectly positioned for this kind of work, free from atmospheric distortion and thermal noise. Its powerful infrared instruments are designed to see the universe in light invisible to our eyes, detecting faint heat signatures of molecules and dust. This capability was needed to analyze the delicate, tenuous cloud of gas and dust enveloping the interstellar comet. The data began to stream back to Earth, a torrent of information. This wasn't just another picture. Webb was performing spectroscopy, a cosmic prism. It breaks down faint light from the comet's coma into constituent wavelengths. Each molecule, water, carbon dioxide, methane, absorbs and emits light at specific frequencies. By finding gaps and spikes in the spectrum, scientists determine the comet's makeup. It's like reading a chemical barcode from hundreds of millions of miles away. For the first time, we captured such a detailed chemical analysis of a pristine interstellar comet. The results were astonishing. The significance cannot be overstated. We've seen interstellar objects before, like the enigmatic Oumuamua and the more comet-like 2I/Borisov. Oumuamua was gone before we could get a good look. Borisov gave us some clues. Webb's power gives unprecedented detail with 3I/Atlas, like going from a blurry black and white photo to a high-def, full-color movie. We are not just seeing the visitor. The first and most stunning revelation from Webb's data was about the comet's breath. As 3I/Atlas warmed, the primary gas it was releasing was not water. Instead, its coma was overwhelmingly rich in carbon dioxide. This was a genuine shock. In our own solar system, comets are often described as dirty snowballs, meaning their activity is driven primarily by the sublimation of water ice as they approach the sun. We expect to see water as the dominant ingredient in their comas, but 3I/Atlas was fundamentally different. It was behaving less like a dirty snowball and more like a cosmic block of dry ice, fizzing away as it neared the warmth of our star. The numbers were what truly drove the point home. Webb's instruments measured the relative abundance of the key molecules, and the ratio was unambiguous. For every 1 part water vapor detected in the coma, there were 8 parts carbon dioxide. An 8-to-1 ratio of carbon dioxide to water is almost unheard of for comets from our own solar system. Most local comets have far more water than CO2. This finding told us 3I/Atlas formed in an environment very different from the one that made Earth and its neighbors. It was a chemical signature that screamed alien. This discovery forces us to rethink models of planetary system formation. The composition of a comet is a fossil record of the conditions in the protoplanetary disk where it was born. The universe isn't just repeating the same recipe. With such a peculiar chemical makeup, the immediate question for scientists was, how and where could an object like 3I/Atlas have formed? The leading theories revolve around ice lines. An ice line is the distance from a star beyond which a substance freezes. We have a water ice line in our solar system. Farther out is the carbon dioxide ice line. One theory, 3I/Atlas formed just beyond the CO2 ice line of its parent star, a frigid region where CO2 freezes into solids in huge amounts, possibly just warm enough that water ice was rare or buried deep. Another idea focuses on composition, not location. Some scientists propose a unique CO2-rich crust on the comet. The comet could still contain water ice but trap deep beneath that crust. As it nears the sun, only the outer dry ice sublimates. That releases the massive CO2 plume Webb detected. Deeper water ice remains insulated and unmelted, for now. If true, the comet's chemistry should change as it heats up. This debate is a great example of the scientific process. One observation opens many testable hypotheses. If the crust theory is correct, water to CO2 ratio should increase as deeper layers are revealed. If the formation theory is correct, that ratio should stay relatively stable. It's a cosmic detective story, and Webb will keep watching. While the dominance of carbon dioxide was the headline discovery, Webb's powerful senses detected a whole host of other interesting materials mixed into the comet's gassy halo. It was a complex and unexpected cosmic cocktail. Significant amounts of carbon monoxide, or CO, were also present, another highly volatile ice that vaporizes at extremely low temperatures. The presence of both CO2 supports the idea the comet is a truly primitive object formed in the cold, dark depths of interstellar space or the outermost regions of its original star system. These are some of the most basic building blocks of cosmic chemistry. Even more intriguing was the detection of carbonyl sulfide, or OCS, not commonly seen in such abundance in Oort cloud comets. Finding OCS provides another chemical clue, but the surprises didn't stop with the gases. Webb's instruments identified tiny grains of water ice mixed with the dust being shed by the comet. This seems to contradict the low amount of water vapor, but it supports the idea water. Ice is present in solid form. It's kind of like seeing ice cubes floating in a fizzy drink. Perhaps one of the most unexpected findings was the faint but clear signature of nickel. Nickel dust could suggest 3I Atlas had a violent or unusual history. So what is this strange alien comet, and where did it come from? Based on its trajectory and speed, astronomers have traced its path backward not to a nearby star, but to a broader region of our galaxy. 3I Atlas is believed to be a relic from the Milky Way's thick disk, an older, more spread-out population of stars that surrounds the younger, thinner disk where our sun resides. This means the comet is not just from another solar system but likely from a much older one. It could be a wanderer that is billions of years old. A true messenger from the galaxy's distant past ejected from its home system long ago. It is important to state clearly, this ancient messenger poses absolutely no threat to Earth. Its trajectory is well understood, and it will pass safely through our solar system before being flung back out into the interstellar void, continuing its endless journey. Its value is not in any danger it presents but in the incredible scientific opportunity it offers. It's a free sample return mission, delivered by the cosmos itself. We get to study a piece of the ancient galaxy up close without having to spend centuries traveling to get there. It's an opportunity that is simply too good to pass up. The best is yet to come. 3I Atlas is still on its way and heading for its closest approach to the sun, its perihelion, in the coming months. As it gets hotter, its activity will increase dramatically. More of its interior will be exposed, potentially revealing the water ice hidden within and changing its chemical signature. Webb and other telescopes will be watching its every move, documenting these changes. There's even talk of redirecting existing spacecraft, Psyche Juice. Getting up-close images and data would be the ultimate prize. This discovery is a perfect example of why we explore. Every time we build a new tool like the JWST and point it at the sky, we find something that challenges our understanding. 3I Atlas is more than just a comet, it's a profound reminder that we are part of a vast, ancient, and incredibly diverse galaxy. It's a story of origins, not just of a distant alien world, but of the raw materials that built our own. The journey of this lonely traveler has intersected with our own, and by studying it, we are learning more about our own place in the cosmos. The thrill of discovery is just beginning. First JWST imaging. August 6, 2025, Coma composition, CO2-rich, CO2H2O approximately 8.1, plus CO, OCS, water ice, nickel dust. Significance. Unprecedented CO2 dominance suggests formation in exotic environments, origin and age, likely from thick disk, possibly 4.6 billion years old. Observation window, visible through late 2025, perihelion tilde Oct 2930, future plans, potential flybys by spacecraft already in the inner solar system. Let me know if you'd like to dive deeper, whether it's JWST instrumentation, chemistry comparisons to other comets, or the trajectory and imaging timeline of 3I Atlas. This comet is a direct sample, a physical piece of evidence delivered to our doorstep. By studying the precise ratios of these materials in a sample from another star system, we can begin to understand the range of possibilities for planetary formation across the galaxy. The discovery of 3I/Atlas reminds us how much remains to be discovered. Add subtitle are now clear and standard.